Welcome everyone, we are from Group 3 and we are going to present our biology project about production of Tempe.
Now, I will explain about the background of Tempe chips. Tempe originated in Java, Indonesia and was accidentally discovered in the 17th century during the process of making tofu. Traditional tempeh is a nutrient-rich food made from fermented soybeans. The soybeans are bound together by Rhizopus oligosporus mold and fermented at around 30 to 32 Celsius for 24 to 48 hours. This process produces a healthy food that is rich in protein and nutrients. Over time, tempeh has evolved into a modern product known as tempeh chips. By fermenting soybeans and processing them into crispy chips, the product has a longer shelf life and is easier to distribute. Now, we go to application of tempeh chips. Tempeh chips are a healthy snack alternative to potato chips because they are packed with protein, fiber, vitamins, and minerals. They are also highly digestible and promote good gut health. With different flavors such as spicy, barbecue, cheese, and seaweed, tempeh chips appeal to consumers of all ages around the world. In addition, tempeh chips have a great market potential because they add value to soybeans, extend product shelf life, and meet the growing demand for sustainable and a healthy food product.
Tempeh chips are made from fermented soybean. The soybean used is scientifically known as glycine nuts, which belong to the kingdom Plantae, family Fabaceae, and order Fabaceae. During fermentation, a fungus called Rhizopus oligosporus grows on the soybean. This fungus forms a white mycelium that binds the soybean together and produces enzymes that improve protein digestibility, reduce anti-nutritional compound, and create the characteristic nutty flavor of tempeh. Next are the physical and chemical perspective. Physically, tempeh chips are thin, crispy, and crunchy with a golden yellow to light brown color. They have pleasant nutty aroma and a savory taste. Their moisture content is only 2 to 5%, which help maintain crispiness and extend the product shelf life. Chemically, tempeh chips are rich in plant-based protein, carbohydrate, dietary fiber, and healthy fats. They also contain important minerals such as calcium, iron, and magnesium. The protein content range from 20 to 35%, while the pH is between 6 and 7, making the product nutritionally valuable. However, the frying process also increases the fat content due to oil absorption.
So, there are two main phases in the biochemical pathway of tempeh chip: fermentation and heat treatment during frying. First, we will use the tempeh starter contains 4 of Rhizopus and mix with the soybean. The soybean are being packed and kept in warm places. So what happens during the fermentation process? The enzyme protease will convert protein into peptide and amino acid. Amylase will break down complex carbohydrate into simple sugar, and lipase will hydrolyze triglyceride into glycerol and free fatty acid. At the same time, phytase will remove phytic acid to release minerals like iron, zinc, and calcium. Lastly, beta-glucosidase will convert isoflavonoid glyphosate into bioactive glycol. The second phase is heat treatment during frying. The Maillard reaction occurs, amino acid react with reducing sugar producing melanoidin, which gives the golden brown color. At the same time, the moisture evaporates as steam to reduce water and create a crispy texture. Lastly, unsaturated fatty acid undergo oxidation and forming lipid hydroperoxide, which then break down into aldehyde and ketone.
Next, I will explain the bioprocess engineering and control factor involved in producing tempeh chip. First, no external enzymes are required because the Rhizopus fungus naturally produce enzymes that break down protein, fat, and carbohydrate during fermentation, and this makes the tempeh more nutritional and easier to digest. And next is pH manipulation. A small amount of vinegar is added to lower the pH to around 5.0, and this creates a slightly acidic environment that promotes fungal growth while inhibiting harmful bacteria. and resulting in a safer fermentation process. And another important aspect is process control. The fermentation temperature should be maintained between 30 and 32 degrees Celsius for about 36 to 48 hours, and the bean must also have the right moisture content, and the packaging should contain small hole to provide enough oxygen for fungal growth. And finally, the yield. After frying, the final tempeh chip typically retain about 30 to 40% of the original fresh tempeh weight due to moisture loss, and by maintaining this process condition, we can produce high quality and consistent tempeh chip.
Now, I will explain the downstream process of tempeh chips. These are the steps carried out after fermentation to produce a safe, crispy and ready-to-sell product. First is slicing. The fermented tempeh is cut into thin slices about 1.5 to 2 mm thick so that every piece cooks evenly during frying. Next is steam blanching. The slices are steamed at 100 degrees Celsius for about 15 minutes. This stops the fermentation process, reduces microorganisms and improves food safety. After that, the slices are coated with seasoned flour batter. The coating enhances the flavor and crispiness while also helping to reduce oil absorption during frying. The next step is frying. The coated tempeh is deep fried at 160 to 180 degrees Celsius until it becomes golden brown and crispy. During this process, moisture evaporates and the Maillard reaction develops the characteristic color and flavor of the chips. And finally, the chips are cooled, packaged and stored. Excess oil is removed and the chips are cooled to prevent moisture build-up, then packed in a moisture-proof packaging and stored in a cool, dry place to maintain the quality and shelf life.
Today, I would like to talk about the advantages of tempeh chips through the triple bottom line concept, which is social and health benefits, environmental benefits, and economic benefits. First, in terms of social and health benefits, tempeh chips are a healthy snack alternative. They are high in protein, rich in nutrients, and naturally gluten-free and dairy-free. Tempeh also contains natural prebiotics that support gut health and improve digestion. This makes tempeh chips suitable for people who want tasty snack while still maintaining a healthy lifestyle. Next, in the environmental aspect, tempeh is made from soybeans, which require much less land and water compared to animal farming. Because of this, producing tempeh chips creates a lower carbon footprint and helps reduce environmental pollution. So, by choosing tempeh chips, consumers are also supporting a more sustainable food system. Lastly, from the economic perspective, tempeh chips can help small and medium enterprises or SMEs grow their businesses. The production cost is relatively affordable and the product has strong potential in both local and international health food markets. This also creates more job opportunities and support the local economy. So now we know that tempeh chips are not only delicious, but they also provide health, environmental, and economic benefits.
Next, I will explain the challenges in production of tempeh chips. The first challenge is microbial contamination. If hygiene is poor or the fermentation conditions are not properly controlled, unwanted bacteria or mold can grow. This can reduce the safety and quality of the final product. The second challenge is inconsistent fermentation. The fungus need the right temperature, moisture and oxygen to grow evenly. If these conditions are not maintained, the tempeh may become weak and break easily during processing. The third challenge is lipid oxidation and moisture uptake. Using old frying oil or storing the chips in humid condition can cause rancid flavors and reduce their crispiness. Proper packaging and good storage conditions are important to maintain product quality and extend shelf life. And the final challenge is raw material quality and production costs. The quality of soybeans directly affects the fermentation process and the consistency of the final product. In addition, advanced equipment such as vacuum fryers and nitrogen packaging systems can improve product quality, but they also increase the production costs, especially for small-scale producers. Overall, these challenges can be minimized through good hygiene practices, proper process control, and high-quality raw materials and suitable packaging methods.
Moving into technical optimizations, we have 5 key areas to elevate our product quality. First, automated incubation is non-negotiable. We must utilize automated rooms to strictly maintain a 30 to 32 degrees Celsius environment. Second, precise measurement is critical. Starter cultures must be measured by weight, not volume, to ensure uniform growth. Third, mechanical upgrades like wet dehulling and mechanical slices will guarantee total skin removal and consistent chip thickness. Fourth, rigorous moisture elimination is mandatory to remove all excess surface water before inoculation. Finally, switching to vacuum frying allows lower cooking temperatures, which preserve vitamins and prevents oil breakdown. Ultimately, high-quality manufacturing means bridging the gap between traditional fermentation and modern food engineering. By integrating automation and vacuum frying, we don't just solve production challenges, we satisfy the triple bottom line, which is prioritizing public health, planet preservation, and corporate profit. Thank you.